Section 1.1 of the Chapter 1 Algorithms document talks about the difference between executing an algorithm and carrying out a discovery and design strategy. It illustrates this difference with the task of evaluating simple numerical expressions in an insightful way. Here, I'd like to just give further examples of how this works. So here's a sum, and we're going to use the insight that we can take a quantity away from either side and add it to the other without changing the sum. So here we can, and the goal is to try to make powers of 10. So it's essentially the same, but it's just organized differently. So here we have a 7 that's close to 1,000. So if we take 300 from the 584 and add it to the 700 here, we'll have 1,000. Let's do that, and you'll have to forgive my problematic number writing. Okay, now, if you notice this 8, this 28 tens here is only 2 tens away from 300. So let's take 2 tens from this 60 here. Let's take 20 from this 60 and add it here, and we'll get 304, because we added the 2 here, and we'll end up with, because we took away 2 here and we added them in here. Okay, now the last one, this 4 and 9, this 49 here is only 1 away from 50, so if we take 1 away here, we'll have 303 plus 1050. Now I can just, there's no carrying involved in this sum, so I've transformed a sum with some complexity into a sum that's fairly simple. We can just write 1, 3, 5, 3. Okay, so this involves a little bit of having to sort of do a little bit of thinking. The standard algorithm avoids thinking, but the problem is that when you're designing computer algorithms, that's what you need to do. You need to think about new ways to solve problems. Okay, so let's go on and try one with subtraction. Now, the principle to use here is if I add or subtract the same amount to the sum, the difference stays the same. So let's do that. We can notice that here we can take this, there's 6 here and 8 here. Well, we can take the 6 away and the 6 and from the 8, and both we can get, this is going to be 256, because we're taking 600 away from both. Okay, now this 8 is too large for the 5. So what we want to do is we want to raise this up. So if we want to get rid of this 8 somehow, and the way to do it is to add 2 here at the expense of adding 2 here. So let's do that. So we'll have 276 minus 107. Okay, and then you see this 6 is less than the 7, but if we add 3 here and add 3 here, that will work to solve that problem. So we end up 279 minus, we've added 3, 110. So now 2 minus 1 is 1, 7 minus 1 is 6, and 9 minus 0 is 9. And that is indeed the right answer, 169. So here, the idea was, we used a different principle, but we used the same idea of sort of applying a mathematical insight and then looking for patterns in the numbers. Well, this was subtraction with this number larger than this. How would it work? How would the same idea work with this number, in which the 765 is less than the 876? Well, If we could drive this one down to 0, we would have the answer over here. Well, right away you can see if I take, because it's a difference, so if I can take away something from both sides and it won't change the value. So I can take away 700 here and 700 here. So I take away the 700 and I end up with just 65, because that goes to 0, and we have got 176. Now, again, this number is less than the 7, so we can do the same thing of subtract 6 from both sides. So we're going to end up with just 5 minus 116. And we can take 5 away from both sides there, and we're going to get 0 minus 111. So the answer is negative 111, which is indeed the answer. Okay, so this was, all of these digits were larger than this one. What happens if you have a mixed thing, in which here, see the 7 is less than 9, but the 6 is larger than the 4, and again, the 5 is smaller than the 4. Well, we can do the same thing. We can just see if the same thing works of subtracting the 7 from both sides to get 65 minus 246. But here, what we can do is we can do something a little different because the instead of pushing this down to 0, because if we did that, that would go less, we can do is we're going to add 4 to both sides to push this up. So if we add 4 here, that's going to give me 105 minus 286. Well, we can push this 1 down again, so we're going to end up with just 005 minus 186. And then we can push this 5 down to 0, which gives us 0 minus 136. Oh, that was a mistake. Here, why did I this is a 5. So when we push this down, we're going to take 5 from the ones place. This is going to be 0 minus 181. And that is indeed the right answer. Okay, so this is how you can use insight to think. Now, this kind of doing arithmetic is actually a little bit more enjoyable than the traditional means, which is you be a machine, you be a computing agent. So I think that's it for this topic.